So we have our trig functions, and we've talked about how it relates to opposite, adjacent, and hypotenuse. And then we talked about how when we can put it on a coordinate system. And when we do that, we can actually assign some letters instead of those words. So instead of opposite, adjacent, hypotenuse, we're going with X, Y, and R. And I also mentioned last time that the reason the hypotenuse is commonly called R here is because we can literally have a circle here that is radius R. And there's a close relationship here, because if we look at the Pythagorean theorem, which for this case is x squared plus y squared plus r squared with these new letters, this equation is also the graph of a circle. So if we literally take this and put it into Desmos, now Desmos, you do need to give some value for r here. So I chose a value of 2. And you can see Desmos will graph out a circle of radius 2. And that's why it's commonly called R there, because of its close relationship here to a circle. And what we're going to do for today is, while R can be any positive value, we're going to say today R is just 1. And we're going to deal with then what's called the unit circle. So a unit circle is simply a circle with radius 1. And we're going to take this 1 and plug it in for all the r's. And then we have these results. Now what's simpler to deal with here is sine and cosine. And remember, once we have sine and cosine, we can get all the other functions. But first, a unit circle, radius 1, then sine is equal to y, and cosine is exactly x then. And try to also remember the difference between the picture versus once you put it on a coordinate system. That in the picture, it's common to think of x as the length here. But remember, on a coordinate system, x and y really mean this point here. This point that the radius terminates at. Because this point here is x comma y. And so again, try to think of these more as a point on the graph. And it literally is the point right here. So if we just throw some numbers in here, and now we can figure out all the trig functions. Because x and y give us all these trig functions, since r is 1. And so we're going to start plugging the stuff in. So for sine, we see y here is 8/17, so we can just plug that in. X, 15/17, so we'll just plug that in. And tangent, now that we have sine and cosine, tangent is sine over cosine. So here is sine, here is cosine. And these 17s will divide out, and you're left with 8/15. And once you have these three, then the reciprocal functions, you just flip the fraction. And so this 1 point, and we can get all 6 trig functions. And I do want to say that this is for radius 1 that we get these simpler results. But don't forget that the more general result does have r in it. And nothing of what we're doing changes here by having, say, r equals 2 or 3. Just means we'll have different numbers. All the math here is still the same. It's just the numbers are easier to deal with when r is 1. So check this out. For question 1, I'm going to give you this point right here. What is secant theta? And I just noticed here that I've made a mistake because I put theta right here on the picture. That's a mistake. What I mean by theta here, I always mean from initial to the terminal. So actually what I mean by theta is this angle here. What is the secant of that angle? Well, secant is the inverse relationship of 1 over cosine. And cosine is x over r, but r in this case is 1, so cosine is just x. And so secant theta is 1 over x. And x, in this case, oops, I ran out of space on the right there. So we have 1 divided by x. X is minus 5/13. And so the reciprocal is then minus 13/5. And that's our answer. So moving on, you've probably seen, or maybe not, a picture like this before. It's just a unit circle with a bunch of the common angles on it and their values. And this is something commonly handed out in a trig class. A picture like this is also in our book. And I am personally not a fan of this picture. I think it's too busy. It's got too much going on. Maybe you like it, though. And the point is that eventually, meaning moving on right now, we're working on how to do all this, is what we're working on. And so far, I started with the 0 to 90 angles. Remember, I said those are the ones to memorize. And then using reference angles, you can get everything else. So you have two choices here, or maybe there's others. But the two choices I can think of here is you can either memorize everything that's on here, which maybe is the route you prefer, or you can go the route I'm now going to show here. That's going with sine and cosine. Because remember, we can get all the other trig functions. Once we have sine and cosine, we can get all the other trig functions. So the 0 through 90, these answers are always divided by 2. And for sine, it increases. 0, 1, 2, 3, 4. And it's the same for cosine, except cosine decreases. 4, 3, 2, 1, 0. So again, you can memorize this table. There's nothing wrong with that. maybe that's what works best for you. Or you can remember fewer things, but then you have to understand the logic of how to get the other trig functions from this. And we already talked about this in last class with reference angles. So consider cosine of 5 pi over 6. Now this answer is on that table. In other words, if you memorize that table, you could just tell me this answer right now. And again, nothing wrong with that. The approach I take is to look at a coordinate system and determine what quadrant 5 pi over 6 is in. And the x-axis is always good to look at here because the x-axis has pi on the left and 2 pi on the right. And these are easy to convert when you have fractions. And so that means they're easy to compare. And so we see this is 6 pi and this is 5 pi. And so we know that the terminal is right here, and this difference, because we know this is 5 pi over 6, so we know this difference here then is just pi over 6. Pi over 6 is our reference angle. And we're looking for cosine. So what do we know about cosine pi over 6? Well, of those, the shorter table to memorize of the 0 through 90 angles, cosine pi over 6 is square root of 3 over 2. And then we look. Our actual standard angle is this. And if we look at this, well, we know the answer is square root of 3 over 2. But we can see this is a negative x direction, and this is a positive y. So a negative and a positive means our final answer will be negative. So it's a little bit more work. Again, it's the path you want to choose. Do you want to memorize the entire circle of angles? Or do you want to memorize fewer things and then use logic to get the other answers? And whatever works best for you. I prefer more of the logic approach, memorizing less, but then learning how to put those, and learning and understanding, I should say, how to put those pieces together. Try another one. Tangent 0. So here's our coordinate system. Here's a 0 angle where the initial and terminal are in the same place. And notice with this 0 angle, I don't recall why I put that in there, Pythagorean theorem. A Pythagorean theorem is always true here, even if you have just a straight line. But the point I wanted to make here is notice with 0 angle that there is no y component. This arrow has no up or down component to it, which means it has a y of 0. This is all in the x direction. And actually, if we plug y into the Pythagorean theorem, we can actually solve and get x equals 1. Now, technically, x is plus or minus 1 if we solve it from taking the square root of each side. But you can see this is in the positive direction. So we choose the positive answer. And then we know tangent is y over x. And now we have our values. We know y is 0, x is 1. And that is 0. And so tangent 0 is 0. So try this out for question 2. What is sine of 3 pi over 2? Now this one is actually a common one to memorize because this happens to be the minimum value of sine, which is good to know. The min and max of sine are 1 and minus 1. Same with cosine. Cosine has a max of 1 and a min of minus 1. But if we look at this, if you didn't know what this answer was, well, we would look at a coordinate system and we would draw our terminal. So remember, here's our initial, here's our 3 pi over 2 angle. So the blue line here is the terminal. And if we look at the terminal, it has no x component to it. X is 0. It's all in the negative y direction. So the end of this arrow is minus 1. And again, remember, we're using a unit circle. So the length of this arrow is the blue arrow is always 1 here because we're dealing with a unit circle. So when the arrows, when our terminal is pointing straight down, we know this is at minus 1 then. And now that we have x and y, we can determine sine because we know that sine equals y. And so we get minus 1. 3 pi over 2 is 270 degrees. It is a minimum point of the sine function, minus 1. The maximum would be at pi over 2, 90 degrees. That's where it's 1. Pi over 2 is, whoops, positive 1. Can't quite squeeze it in there. So the last topic in the book here isn't necessarily anything new. You learn about even and odd functions in algebra, and we're just going to talk about the even and odd functions in trigonometry. So just to give you a quick recollection of even and odd functions, let's look at the cosine function. And just choose any value. I'm going to choose one right here. And then once we choose some value, we're going to choose the negative of that. Whoops. Which is over here. And notice these are the same output. So if you plug in a positive number, that output is the same output as when you plug in that negative number. And so we would say this is an even function. Whether you plug in your positive value or your negative value, you're going to get the same answer. And so in algebra, you learn a definition of an even function. If you plug in the negative value, you get exactly the same thing as if you would plug in the positive value. That's an even function. And if we look at cosine, that means if you plug in a negative angle, you get exactly the same answer as if you would plug in a positive angle. Now for sine, let's pick any point we want positive on sine here. Just going to pick right here. And now we're going to pick its negative number value there. So negative would put it over here. And notice in this case, the outputs have the same magnitude, but they're different in sign. So this is the plus, this is the minus. They're the same number. They just differ in sign. And we say then that this is an odd function. If you plug minus x into the function and you get the same output as positive x, but with a sign change, that's an odd function. So for sine, that means if you plug in a negative angle in the sine, that's the same thing as plugging in a positive angle and then multiplying it by a negative. So let's say we have this scenario. Here's our standard angle in the negative direction, minus 30 degrees. What is sine of minus 30 then? Well, sine is an odd function, which means this minus sign we can basically pull out and stick in front of sine. And sine 30 is something to memorize. So 1/2 is sine 30, and there's our minus sign. So sine of minus 30 is minus 1/2. So how about cosine of minus 30? Well, cosine is an even function, which means plugging in a negative value is the same thing as plugging in the positive value. And we know what cosine 30 is, because it's one of the answers we should memorize. Square root of 3 over 2. So how about for question 3, what is tangent of a minus 30? So now that we have sine and cosine, remember we can always write tangent in terms of sine and cosine. Now sine, we know, is an odd function. So this minus sign we can pull out in front of the sign. And then cosine is an even function, which basically means this minus sign doesn't matter. And so we get this result. And we know what sine of 30 is. It's 1/2. We know what cosine of 30 is. Square root of 3 over 2. These 2's will divide out. And so we're left with minus 1 over square root of 3. Now, I should say that I'm okay with square roots in the denominator. My math lab is not, however, and they do require you to rationalize the denominator. Rationalize means getting rid of square roots. So to get rid of this, we would have to multiply by square root of 3 over square root of 3 to satisfy my math lab. And so the answer there then for my math lab would be square root of 3 over 3. So in summary, we talked about the 6 trig functions again. We have been, I think, for every lecture now, but they've been slightly evolving. So notice first we talked about initial and terminal sides and how to talk about an angle. And then we talked about the right triangle and all the ratios you can make with those sides. And then those ratios we called opposite, adjacent, and hypotenuse. And then we took that idea and we put it on a coordinate system. And on that coordinate system, we could start talking about x, y's, and r's. And so our trig functions evolved then into now having these ratios that are of x, y, and r. And for today, we simply looked at the unit circle where r equals 1. And these were the relations then we get when r equals 1. And again, this section is stressing. You need to burn into your brain trig function results, the basic ones here. And I see basically two options. You can either memorize that unit circle of angles, which you can find all over the internet. If that works for you, then that's what you should do. Or maybe you may like my approach, where I only focus on sine and cosine, and then I use the logic of math to get everything else. So they all require memorizing in some manner. And the last thing we talked about here with sine and cosine is that sine is an odd function, which gives us this relationship that can be useful. And cosine is an even function, which then gives us this relationship, which can also be useful. And that is this lecture. I'll talk to you in the next one.